Hi guys, I'm Tom Koo from Tom Koo Live channel, and today I have Ivan, and Ivan's project name is Dispatch. What was it again?
Dispatch Labs.
Oh yeah, Dispatch Labs. So Ivan, the audience mostly like me right now. Okay, I just know the name of you and your project,
Yeah.
and I don't know exactly what it is about. And I mean, it's your responsibility to kind of let us know what it is about. All right?
For sure.
Go ahead.
I'm Ivan Goldensohn. I'm the Chief Ecosystem Officer and one of the co-founders at Dispatch Labs.
Well, what does that mean? Chief Ecosystem? I never heard about that kind of position.
Yeah. So when I started, my title was Chief Marketing Officer, and I
Right.
come from a marketing background, business
Right.
development background. I ran $100 million portfolios of products in the video game industry and whatnot. And what we realize is that Dispatch is a protocol, right? It's a platform on which you could build ideas and let them grow and succeed. And in order for a protocol to survive, it's not just based on the technology. It's based on adoption and ecosystem. And we see the ecosystem as sort of being this interaction of partnerships and developer relations and working with other groups of fundraising and not just talking to investors, but making investors partners who can reach out to their networks, talking to enterprises. At a very high level, the goal of Dispatch is to get blockchain to the point where millions and tens of millions and hundreds of millions of people all over the world are positively impacted on the day-to-day by blockchain applications in the back end.
All right.
And similar to how HTTP, I think most people probably don't know or care what hypertext transfer protocol is.
Right.
But email makes their lives a lot better. And HTTP was a system of tools that enabled an ecosystem to form around the internet, of which all these lovely things that make our lives better, from being able to hail a car with your phone and
Right.
take Uber somewhere, to be able to order food to your house or pay your bills online. And Dispatch is sort of a tool set to enable that. So the reason we went with Chief Ecosystem Officer is really so that I can be a support vector for our developer relations guy and our partnerships guy. We have this incredible team of really brilliant people that work together. And they're all smarter and better at their jobs than I am, and I'm just here to help out and to support building that relationship and that ecosystem of networks so that we can sort of really ensure that this thing changes the world.
Well, I mean, the relationship builder is not going to be the only test for a chief CEO. It's like a CEO, right?
Yeah.
Chief ecosystem,
So we also have a chief executive officer, a guy named Matt McGraw, who's super brilliant. We're really lucky to have a super diverse team. We have this tech whiz kid named Zane Witherspoon, who's like one of the smartest people I've ever met. He was actually denied entrance to UC Berkeley's programming school and is now a guest lecturer at UC Berkeley's programming school. And he's 21.
Yeah.
But yeah, it's about having a lot of pieces that work together. I think it's also about acknowledging that nobody knows all the answers in blockchain. This is such a new world that's evolving as we watch it grow. And being able to have someone who can step into different roles and support all the different groups within the company and say, I've had a very diverse work experience. I've done central nervous system research in the pharmaceutical industry for companies like Janssen or the National Institute of Mental Health. Mm-hmm. I've done video game marketing for wargaming.net or mail.ru and my.com, and all the way back to, I was a waiter. I waited tables.
Whoa.
I've managed restaurants. I've trained
Really?
servers. Yeah, whatever.
Wow, that's
I was
extremely diverse.
I motorcycled around the circumference of North America.
Oh my God.
I did international development in Rwanda, working with coffee and dairy farmers.
That's great.
So I have this sort of jack of all trades ability to go in there and help these different people. And we're really lucky to have built an incredible team and culture. And Chief Ecosystem Officer is partly building that network and partly saying that we're a flat organization and we're all there to support one another. And I can be pulled into any conversation and help people like Shadon, our VP of Investor Relations, who's brilliant, or Jake Kuzarak is a fantastic partnership manager.
But, I really have a question. I have to pull it out. So, it seems like, you guys are actually providing kind of an ecosystem for blockchain developers, right? So, I saw, for instance, what is your platform different from how is your platform different from these various ICO platforms? You understand what I'm saying, right?
Yeah, of course.
There are platforms, they provide, smart contract editing or build up, functionalities. There are ICO platforms that actually try to connect, find the right coins and then make it compliant with security laws and then connect to the investors, right? I think Dispatch Labs is totally different.
Yeah. So let me address that by sort of going through the tech a little bit. So Dispatch was formulated to say, how do we build a system that enables all sorts of different use cases that really will impact people's lives, whether that's electronic health records management systems or big data analytics systems or content delivery networks or peer-to-peer streaming services. So Dispatch uses a new consensus mechanism, which Zane Witherspoon invented, called delegated asynchronous proof of stake.
All right.
And that's really the scalability side of it. So DAPOS, as we call it, is super, super fast. We've seen up to 107,000 transactions per second on our testnet.
How many?
107,000. But I'll specify that's in hyper-optimal conditions on a private testnet. I think
right.
more likely when we launch, we'll see between 10 and 20,000.
Okay.
But Dispatch's testnet is live right now. It's accessible to the public. So I beg you, don't take my word for it. Go check those speeds out yourself. And I think that one of the industry problems we see right now is people making huge claims and not backing them up.
All right.
So we have a very, very scalable platform, which is both super fast and has 0 transaction fees. We actually have 0 fees on the network. We tie that into an off-chain.
I mean, how's that possible? Okay, right now I understood. It's a blockchain, right? It's a mainnet, right? A platform, right? Mm-hmm. And I mean, I have 2 questions. First is DAPOS, because I'm not very familiar with that term. Okay. I know POS, I know POW. I'm not very in depth, but still, I know the concept. And then, turn it into a 0 fee. How is that possible?
Yeah, so DAPOS basically takes the technology of a DAG, a directed acrylic graph, and the gossip layer from a DAG, and overlays that.
What is a DAG?
Directed acrylic graph is like what Raiden or Nano or Constellation Labs are doing. It's sort of what Hashgraph and Plasma are doing. It's a new technology that is much, much faster, but it's also not entirely proven in the real world yet. So we've balanced a DAG technology, the gossip layer, with a DPoS-style system like what Steemit or BitShares or EOS is using.
All right.
So we have a validated shared ledger where we've sacrificed a little bit of decentralization to guarantee speed and low cost to be enterprise focused. So it's still a distributed system, so it's not like Ripple's proof of authority where we control the nodes. The nodes are decentralized. But we have 20 or 30 or 100 nodes that are validating the whole transaction system instead of an infinite number in the case of Bitcoin or a POW or POS system. And in order to remove transaction fees, Zane came up with this brilliant staking mechanism where you have to put a token against your transaction. And the more transactions you process, the more tokens you have to stake. Now you get those tokens returned to you 100%. You're not paying them, you're just locking them up for a short period of time.
All right.
But that means that if you wanted to spam the network or do something to negatively impact it, you'd have to control more and more and more tokens in order to do that.
Right.
So on Dispatch, instead of saying you have an ongoing cost that's an amount of fees, you have sort of an upfront cost to acquire those tokens or to get them for free from us through some of our support programs.
Right.
And you use those tokens every time you're processing information or transactions, and then you get them returned to you after a cycle. So this means that we disincentivize spamming because you have to hold more and more stake in order to process that amount of movement. But it also means that instead of having an ongoing back-end SaaS cost like paying AWS or paying Google Cloud, you basically just need a holding mechanism, which can sort of act as a value store for the company in terms of them keeping those tokens.
All right. So did that explain, the 0 fee structure?
Yeah. So the fees on
because the block builders or the validators, I mean, they must be compensated, right?
They are. So
how they are?
That's exactly right. So instead of paying those people fees, we pay them a salary. So there's a salary for the delegated nodes within the network, which is an inflation mechanism. So those tokens are minted. And that salary is voted on through the governance of the platform by all of the distributed people who are participating.
All right.
So the more that volume goes through,
the salary, you must have some kind of, reserve for that, right?
So the salary is the inflation mechanism of the currency. So we mint the coins to pay that salary in the same way that making a block on the Bitcoin network mints new coins. That being said, it's worth considering that part of the reason why rewards have to be high for Bitcoin or Ethereum or POW or POS is that it's a lot of energy cost and it's a lot of hardware cost.
Right.
Because in a DPoS or a DAPOS system, the nodes are working together to validate transactions, our network is super efficient. The amount of energy that it will take to run millions of transactions on dispatch is less than one small server rack.
All right.
So instead of Bitcoin right now using more energy than the country of the Netherlands, the amount of electricity that it will take to run the entire dispatch network is probably less than what's running the computers in this room right now.
All right. I mean, I'm really sorry because I think I'm a little bit maybe too ignorant, but I still don't get it. How you can come up. I mean, I know the salary, all right, and then can you explain about it's like minting? You said, right?
Yeah.
And then the other thing is how this consensus system can make the process so efficient. That part also I didn't understand. I'm really sorry.
Yeah, no, not at all. So that's not a technology we invented. That's sort of the core tenet of the DPoS, the Delegated Proof of Stake system. And DPoS is saying that in a POW or POS system, you have a wasted work, right? So POW, we're breaking a cryptographic hash in order to justify creating the next block.
Right.
And breaking that hash is like cracking a code, but it's not a code to anything. We're not like figuring out math formulas to put satellites into space, whatever it may be. We're just breaking a code to show that you're the fastest and you have the right to the next block.
Right.
In the case of a DPoS system, there's no wasted work. The nodes are working together in order to validate the transactions.
All right.
So every time a transaction is updated to the network, and we do that asynchronously. So instead of having blocks, we just process transactions as they come in. You don't have to break a code. You don't have to do any extra work. Those nodes are voted into place through the delegated proof of stake system and can be updated or changed over the network throughout time, which means that it's way, way more efficient. The cost for those miners is much, much lower, which means the salary reward has to cover a much lower, cost of electricity and hardware.
All right.
And that enables us to have a system. And that means that for applications like banking the unbanked or providing identity or running SaaS-level architectures with millions of transactions and data points moving around, those little transaction fees add up very quickly.
All right.
And Dispatch is completely backwards compatible with Ethereum. Not only can you port an Ethereum DApp over to Dispatch, you could port the state of your smart contracts, so active tokens in escrow or whatever you want.
Okay.
And that means that for a lot of these applications that are doing really exciting things that can change the world, but that can't reach massive scale right now because Ethereum is a fantastic store of value and I think has changed the world with the ISO landscape. I love Ethereum. I spoke at an event with Joe Lubin a week ago. He's a great guy, like nothing against that project. It's also not scalable enough to handle enterprise-level applications. So Dispatch is going to be a very appealing home for many of those Ethereum DApps to be able to easily move over and say, oh, wow, now we're in a new place with no fees that's way, way faster.
All right. But I mean, your platform is not launched yet, right?
No, so our live testnet is public right now, and if you go to dispatchlabs.io, you can see that, or join our developer community on Discord or on Telegram, t.me/dispatchlabs. And don't take my word for it. Go check it out. We're happy to send you some test tokens.
Sure.
And then, we're looking at having a mainnet launching in late October, early November, at which point the network will be live. And there's already several projects that are building on Dispatch right now.
All right.
So Choreo, for example, is a great project that's turning the ability to interact with data into a human language question. So think like Wolfram Alpha plus Alexa. You could say, hey, who's my best sales lead right now? And instead of getting a bunch of charts and mumbo jumbo, it'd say, this is your best sales lead.
Right.
Or, what brand of cornflakes should I buy?
Okay.
Bucket Technologies, which is incubated out of Arkansas through one of the large companies out of Bentonville. They're trying to remove coins from the economy with a very cool dual stablecoin model. They're building that on Dispatch.
All right. But anyway, I mean, the POS system and the DAPO system actually, basically, I mean, both of those systems are more efficient than POW, right? There's no doubt about it, right?
I mean, so Bitcoin, processes after the SegWit processes 7 transactions per second.
But in the aspect of collaboration, what is the difference between the POS and the DAPOS?
Yeah.
Isn't it the same? I mean, the mechanism.
Not exactly. So DPoS, and really the model for this is the live tokens that are using it right now. So, Steemit, BitShares, EOS groups like that.
Right.
DPoS, they're working together, whereas POS still is using stake to establish how much power people have within the network, but still has a work mechanism associated with it.
Yeah, but DPoS is very similar to DAPOS, right?
Yeah, so exactly. So DPoS is very similar to DAPOS in terms of how we select delegated nodes and how we validate transactions to the network. The big difference is that DPoS still has blocks, which is a fundamental limit on how fast you can get.
All right.
Dapos processes transactions asynchronously by using the technology from a gossip layer, from a DAG.
Actually, that was a little bit difficult, and I don't think people will understand that. You understand what I'm saying? Because async or what?
Asynchronous.
Asynchronous. I think I know the word itself, but still from a technological point of view, I don't have any idea what's the so different from the DPoS.
Absolutely. So. Okay, so let's talk about shared ledger tech in general for a second here, right? And the example that I use for this is a poker game. So you get together with your friends and you play poker once a week, and you fill out a sheet of paper that has all the transactions and how many poker chips each person has.
Yeah.
In a shared ledger, everybody gets a copy of that sheet of paper saying we each have a copy of it. So next week I can't say, oh, Tom had these tokens and I didn't. Everybody else can check it, right? In a POW style system, two things are happening. One is, let's say, Tom, you're in charge of updating the ledger. We're saying, Tom, you're going to have to break this sheet of math problems first before you get the right to do that. And then everybody's, we'll give you a couple bucks thanks for doing the work, right? So first you have to do that sheet of math problems. And two, you have to collect every one of those transactions onto a piece of paper together. Everybody gets a sheet of paper. A synchronous system is saying that instead of having to collect them together onto a sheet of paper, we can process them as single transactions and still update everybody's paper. So, you don't have to break a sheet of math problems. We've gotten together as a group and voted and said, hey, we trust Tom. He's smart enough to do this, so he's going to be our delegate. And B, instead of handing out a sheet to each new group, every single time tokens move, someone wins a hand, loses a hand, plays some poker, every single person's notebook is going to get that transaction updated. Mm-hmm. So block time, we talk about 10-minute block times or 15-second block times, that has a limiting capacity, and this is like mathematics that's beyond my understanding, right? But it's basically saying fundamentally you at some point reach a point where you can only get as fast as your block time allows. That's why Bitcoin sort of hit a functional maximum speed and suddenly couldn't keep up with the amount of movement that it needed to process. Mm-hmm. That's why CryptoKitties basically broke Ethereum, because we couldn't keep up with the volume on the network because everything had to be pressed into a block, and whenever it didn't fit on that sheet of paper, we had to push to the next one, and it just builds up and builds up. That's why people talk about SegWit and Nano and Plasma and Lightning and all of these exciting technologies to make those older systems faster. We kind of look at those older systems as being, adding layers to those older systems is sort of like supercharging a steam engine when we have a mag drive train on the other side of the tracks. And I think there's a lot of great technologies out there right now that are being built, like Dispatch, like EOS, like Hyperledger or Hashgraph, that are functionally a lot faster from their core components. And the asynchronous element of Dapos is one of the new technologies that we've sort of come up with, specifically Zane and Greg McGregor and the team out of San Francisco, in order to remove that theoretical limit on how fast we can get.
All right.
So Dispatch can get faster over time as we optimize the network.
Wow. I mean, because from a technological aspect, I can't say that I fully understood it, but I mean, especially this, I think the metaphor was very good with the poker. Mm-hmm. But I mean, what do you mean by separating out all the transactions and just share a copy of that transaction? I mean, it seems like then. Is it like when you see a certain transaction, you don't see the whole thing, but just that transaction? Is that what it means, or?
No, we see the whole transaction. It's saying that instead of collecting them all together and treating them as a package, we treat them as individuals.
All right.
So every time a transaction's processed in Dapos on the dispatch ledger, that transaction is passed to the nearest local node who validates it through a gossip protocol, which is. Trust me when I say you're okay for not understanding that, because I barely understand it myself. That's some crazy advanced math stuff. It uses memetics and all kinds of different stuff in order to validate things. Once that layer of validation has occurred, that single transaction, instead of collecting a group of them, immediately gets passed to all of the delegated nodes through the system. So each of those nodes basically has the chance to verify it and add it to the ledger of which each of them has a copy. That's our shared ledger, right?
I mean, I mean, when they verify it, actually, don't they have to see the whole, history, whether this is really fitting in here? But if you do it in that way, I mean, there could be loss of link between the previous blocks and the most recent blocks.
So that's one of the concerns with pure DAG technology versus our technology.
Yeah.
So in the DAPO system, each of those delegated nodes has a shared ledger that goes all the way back to the beginning, just like Bitcoin or Bitcoin Cash or Ethereum. So what we've done with this technology is basically taking, on a high level, we've taken some really cool like fringe technology stuff, like, wow, this is the coolest new thing that's coming out, it's unbelievably fast, and it works, but we don't know if it's like ready to be functional for the real world based on some of these concerns we have.
Right.
And we've tied it into a more traditional system that is working on what we know works within shared ledger technology.
All right.
So that we can validate it through all the nodes.
All right.
So within a second or two of a transaction being passed, so let's take a use case, right? Electronic health records are a passion of mine, right? The fact that a veteran in the United States has to physically get their information shipped or driven when they move to a new place in order to continue getting medical treatment, I think is a huge problem.
It is.
So putting medical records on the blockchain is a really great way. You have an immutable record of when that information is there. Dispatch's other technical element is the Dispatch Artifact Network, which is a sort of like an IPFS style data management layer with custom properties per application. So that's a perfect use case for Dispatch, right? You store that information in that ledger. Each time the patient has a test or a blood sample or meets a doctor, we get a record of that, and then that patient can access their whole history, or the doctor can access their whole history. So let's say that you've just had your blood test. We've collected the data, and now we want to put that onto the dispatch ledger.
Right.
The doctor can go in and update that. That transaction sends the data to the DAN, to the Dispatch Artifact Network, and encodes it to say it's got to be HIPAA compliant, GDPR compliant. We have to protect the privacy of that patient's data.
Right.
And then we take an address, a hash that stores where that information is stored, and we use a Kademlia distributed hash table, which is stored within every node on the chain, which is like the address book, which is anonymized but knows where that data is stored. And then we update that to the ledger so that everyone can say, okay, we see that something occurred and this data is stored here, and we validated that. That transaction is passed to the local delegated node. That delegated node processes it asynchronously, which just means that it's not putting it into a block. It's saying, okay, we have it. Can we validate it against the record that we own? So just that one node owns a record and validates it right there. So that at that level, we're stopping double spend. We're stopping those problems, right? As soon as that local node has validated it, it passes that transaction to every one of the other nodes to also validate it against their ledgers. So if someone else has information that disagrees, it's going to push it back to that first ledger and say, hey, you validated it, but it's invalid based on the information that we have. Which means that on the top layer, we're processing things very quickly. But as soon as something gets passed through the network, it gets added to everybody's shared ledger, which means we have an immutable history all the way back to the beginning of the time, to the Genesis block, even though it's not really a block because there's no blocks, but you know what I mean. And gives us this permanent shared ledger record. So it's really a pragmatic look at how do you build an enterprise use case.
I don't think that solves the double spending potential, right?
Well, the double spend problem we're solving through sort of a combination of the existing protocols and the DAPO system.
But before the verification, I mean, if it turns out to be invalid, in the meantime, there could be a double spending potential.
Yeah, so there's two places that can be pushed back. One is at the first layer through the gossip protocol. The second is through the validation layer.